and also it is inversely proportional to NQ. So then we have noticed that for n equals to 2, hydrogen atom, that n equals to 2, for n equals to 2 state, it means that n is fixed, and for hydrogen atom, that p state, that L equals to 1 for hydrogen, we have noticed, and for helium plus. So state was same, n equals to 2, but also L is same. But here, if you see that splitting, amount of splitting of p orbital, that is 2p 3/2 and 2p half. Here 2 is not principal quantum number. This is actually multiplicity. That we'll discuss during that when we'll discuss that spin or LS coupling. So that is basically known as multiplicity. That is 2s plus 1. Okay, that is known as multiplicity. Okay, so what I am saying, that amount of splitting for hydrogen will be small as compared to helium. Okay, this is the case of helium. So n is fixed, and again that state is same, 2p 3/2, 2p half. But this splitting will be large for helium as compared to hydrogen. Now, if you take a large Z number like lithium, beryllium, sodium, then if you take that state fixed, but that splitting will be large because that depends only on Z to the power 4. Now let us take hydrogen case. So in hydrogen, for n equals to 2, L equals to 1, there is a possibility there will be splitting. But if you go to higher state, like n equals to 3, there also you'll get L equals to 1, right? But for that case, that splitting, L equals to 1, there also you'll get p orbital, right? Same thing we'll get 2p 3/2, 2p half, right? But that splitting will be less as compared to n equals to 2. So if you increase that n or principal quantum number for a given L, for a fixed L, the splitting will be less if you increase that n. Okay, so this is the effect of spin orbit coupling on Z and n. Okay, now if you understand this concept, then we'll do one or two problem. Is it clear to all?
Yes, sir.
Okay. Now suppose the Hamiltonian of two spin system is given as H equals to J S1 dot S2. Okay, so Hamiltonian of two electron system is given, J is some constant, S1 dot S2, S1 and S2 are spin angular momentum of electron 1 and electron 2. Now the question is, what will be the energy difference between maximum energy and minimum energy states? So question is, what is the energy difference between maximum energy and minimum energy? Maximum energy and minimum energy states. So if you S1 dot S2, if you write in proper way, you will see there will be two states are there. So that corresponds to two different energy. Okay, so one will be the maximum, another will be the minimum. Okay, so that you have to calculate. So shall we proceed? So after discussion this, I'll give on the general formula that someone was asking, Abhishek and Mohit, that how we'll check that polarization. So that we'll discuss in later after finishing this part. So how we'll do this part?
We will calculate the value of S.
So yes, S1 dot S2. So total S will be how much?
0 and 1.
Total S will be how much? How will calculate? So
S1 plus S2
S1 plus S2.
and उसको square करेंगे.
So if you square it, then you will get S1 square plus S2 square then you have 2 S1 dot S2. Okay, so from here you can clearly see that S1 dot S2 will be how much? S square minus S1 square minus S2 square divided by 2. Okay, now I'll substitute this expression in this Hamiltonian equation. So basically you will get H equals to J by 2 S square minus S1 square minus S2 square. Okay, so in terms of energy, so energy will be how much? So basically psi H psi, right? So if you calculate that energy from Hamiltonian, this is the way you know that from quantum mechanics. Now the eigenvalue of S square will be S into S plus 1 H cat square. For S1 square, it will be S1 into S1 plus 1 H cat square, and similarly S2 square. That formula is same. So if you do this, you will get J H cat square by 2, right? Then you will get S plus 1 minus S1 plus 1 minus S2 plus 1. So this is the energy expression. So if S1 and S2 are half, so S can have two values, right? So if S1 and S2 both are half, so S can have S1 plus S2, or S1 minus S2, right? So you can see that energy depends upon this S. So S1 plus S2 will give maximum value of X. So at that time, your energy will be maximum. When S1 will minus S2, if you do, it will give minimum value of S. So obviously that energy will be least. So just do it and tell me, is it clear this part?
Yes, sir.
Okay.
So it is JH cut square by 4 for S equals to 1.
So for you are saying for maximum energy, right?
Yes, sir.
Okay, good. So when S1 equals to half, S2 equals to half, and your S is 1, that time you will get maximum energy, that will be E max, and that will be J H cross square by 2. So S into S plus 1, obviously S is 1 here, so that will give you 2. And S1 into S1 plus 1 will give you 3 by 4, because S1 is how much? 1 by 2, so obviously it will give you 3 by 4. And same thing you will get for last factor, that will be 3 by 4. Because S2, again, it is half. So half into half plus 1, that will be 3 by 4. So if you solve it, 2 minus 3 by 2, it means it will be half. So simply you will get J H cat square by 4. Okay, so this is your maximum energy. Now, second case, when again S1 and S2 are fixed, so it will be half, S2 again it will be half, and S is 0. At that time, you will get minimum energy. So it will be E mean equals to J H cross square by 2. Then obviously, since S is 0, this factor will be 0. And there will be no change in this factor, because again, S1, S2 are same like earlier case. So it will be 3 by 4 minus 3 by 4. So then how much you will get? This factor, if you add this, it will give you minus 3 by 2. And this is 1. So it will be how much? Simply 1 by 2. So 1 by 2 into minus 3 by 2, it will be 3 by 4 J H cross square. Since they asked to calculate that energy separation, so obviously energy separation, let us denote this notation delta E. It will be how much? E max minus E min. So E max was your J H cross square by 4, and it was minus, so minus plus J 3 by 4 J H cross square. So it will be simply J H cat square, right?
Yes, sir.
So you have spin-spin interaction splits a single energy level into two parts, and that separation of these two parts, two levels will be J h cut square. Okay. So now I'll do another interesting problem. Is it clear to all?
Yes, sir.
Shall I erase?
Yes, sir.
Yes. Yes, sir.
Now, suppose you have this kind of transition from 2p, again 2 in that is multiplicity. Okay, keep in mind that everything I'll discuss when I'll go to that spin orbit coupling, or sorry, LS coupling. That time I'll discuss what is term, what is sublevel, what is component. That time I'll tell you. And this is your 2s state. So there is a transition before spin orbit, and that transition, that corresponding wavelength is given. That corresponds to, when there is a transition, that corresponds wavelength is 6521 Armstrong. Now spin orbit coupling will not split this line, but obviously there is a splitting of this line. So that when there is a spin orbit coupling, that splits this line into two lines. So when there is a so before spin orbit coupling, there is a single transition, but due to spin orbit coupling, this single line will break into two lines having wavelength
Sir, what
lambda 1, lambda 2. They didn't give you that lambda 1, lambda 2, but they told you that separation between lambda 1 and lambda 2, delta lambda is given. Delta lambda is given, that is 0.14, 0.14 Armstrong. So spin orbit coupling splits a single line or single transition 2p to 2s into two lines, and the separation between these two lines in terms of energy is given, in terms of wavelength, that is given 0.14 Armstrong. Okay, this corresponds to 2p 3/2, and this corresponds to 2p half. Then that question is, how much will be that energy separation of this 2p 3/2 and 2p half? The question is clear? Is the question clear? Spin orbit
Yes, sir.
coupling splits a single line or single transition between 2p to 2s into two lines having different wavelength, and separation between these two wavelength is 0.14 Armstrong. Then how much will be the energy separation between these two lines, 2p 3/2 and 2p half? How will calculate? So very simple question. Just you have to write E equals to hc by lambda. Now you can clearly write delta E equals to how much? hc by lambda square delta lambda. Minus will be there, but I'll take mod. So let us take mod. So it will be hc by lambda square delta lambda. Now you know the value of hc. hc in terms of electron volt, can you tell me? hc is how much? 1240
electron.
eV nanometer.
Yes.
Okay, so we can write 1.24 into 10 to the power 3 eV. Okay, and now nanometer will be converted to meter, so I have to multiply it by minus 9. So how much will get? 1.24 into 10 to the power minus 6 electron volt meter. Is it clear? So I'll substitute this value, 1.24 10 to the power minus 6 electron volt meter. Now delta lambda we can write in terms of meter, right? So it will be how much? 0.14 into 10 to the power minus 10. Similarly, that lambda we can convert into from Angstrom to meter, so it will be 652 10 to the power minus 10 square, right? Okay, so if you calculate it, you'll get 4.08 10 to the power minus 5. Unit will be what? So this, when you have converted, it is in meter, right? And this converted, it will be meter square. So meter square, this meter will be cancelled. Of course, that unit will be electron volt. Okay, because delta lambda, it is in meter, lambda square, meter square, and you have 1 meter. So this meter makes meter square, and you have meter square in denominator. That will be cancelled. So electron volt will be left. So that is the energy separation between these two lines. That this will be 4.08 10 to the power minus 5 electron volt. Is it clear?
Yes, sir.
Okay. Exactly this kind of question you will get. Shall I proceed?
यस सर. सर मतलब स्पिन ऑर्बिट कपलिंग का कोई यूज ही हम नहीं कर रहे.
नहीं, स्पिन ऑर्बिट कपलिंग का कोई यूज नहीं है यहाँ पे. स्पिन ऑर्बिट कपलिंग का कॉन्सेप्ट है ये लाइन दोनों ब्रेक हो जाएगा. ठीक है. एक दूसरा मेथड भी है, वो मैं बता सकता हूँ. जैसे इसका कॉरस्पॉन्डिंग आप एनर्जी निकाल सकते हो, राइट? ये कितना हो जाएगा? E1 इक्वल्स टू हाउ मच? hc बाई लैम्डा 1. ठीक है. E2 कितना हो जाएगा? hc बाई लैम्डा 2. बट ये जो एनर्जी, ये जो इमिट हो रहा है फोटोन, इसका एनर्जी निकाल सकते हो. इतना एनर्जी है उसका, है ना? इसका एनर्जी इतना है, राइट? डिड यू गेट व्हाट आई एम सेइंग, सौतन? इसका एनर्जी इतना है, इसका एनर्जी इतना है. अब दिस टोटल, ये गैप माइनस ये गैप करोगे तो ये गैप मिल जाएगा ना. ये आपका मान लो E1 गैप है, इसको मानो E2 गैप है. ठीक है. आपको गैप कितना निकालना है? ये निकालना है. तो E1 से E2 को माइनस कर दोगे तो फिर ये निकाल के आ जाएगा, है ना? डिड यू गेट सौतन व्हाट आई एम सेइंग? हाँ, ये गैप से इस गैप को माइनस कर दोगे, बचा यही रहेगा. तो E1 माइनस E2 करो. E1 माइनस E2 अगर करोगे आप, फिर क्या मिलेगा? hc लैम्डा 1 माइनस लैम्डा 2 डिवाइड बाई लैम्डा 1 लैम्डा 2. ठीक है. अब लैम्डा 1 लैम्डा 2 इज डेल्टा लैम्डा, दैट इज गिवन. अब लैम्डा 1 लैम्डा 2, ठीक है, they are very close. I mean, their separation you see only 0.4 angstrom. So what you can write in terms of, in place of lambda 1 lambda 2, you can write lambda 1 almost equals to lambda, lambda 2 almost equals to lambda. So basically you will get hc delta lambda lambda square. ठीक है. इस way में भी कर सकते हो.
Okay.
Because lambda 1, if see their separation is so small, so we can write lambda 1 close to lambda and lambda 2 close to lambda. Just you have to substitute in place of lambda 1 and lambda 2. Just you substitute lambda square, you will get. So concept is very simple. You have to calculate this gap minus this gap. It will give you this gap. Okay. So if you have done, we'll do one more problem. Then we'll go to Darwin term. And that is real physics is there. So let यह समझ में आया ना ये वाला पार्ट आपका?
Yes.
Okay. समझ में आ रहा है सबको क्लास में?
Yes sir.
ठीक. Again, I'm giving that spin orbit Hamiltonian HSO, that is A L dot S. Spin orbit Hamiltonian splits P state into two parts. Okay. This is corresponds to 2p 3/2, and this corresponds to 2p half. So I have to calculate this gap. कितना आएगा? हो जाएगा?
Yes.
So I'll not write L dot S because yesterday I have discussed these things, right? So if you write L dot S in terms of J, L, and S, it will be A by 2 into Z plus 1, then minus L plus 1, then you have S plus 1, right? So this is known, this is your energy, right? Spin orbit energy. Okay. Now, J can be what? So your L is fixed. L is how much for P on, and S is, of course, electron is spin half, and J can have two values, right? So J is mod L plus S to mod L minus S. So when you will do mod L plus S, L is on, S is half, so it will give you 3/2, and L is L minus S, so L is on, S is half, 1 minus half, it will give you half. Okay, so two possibilities are there. So of course, when J is maxima, energy will be maxima. When J is least value, that will give you least energy. So one possibility is L equals to 1, S is half, and J is 3/2. So that time you will get maximum energy ESO. ESO that corresponds to J equals to L plus half equals to 3/2, right? So that will give you how much? A H cross square by 2, and what will be that factor? 15/4, right? 15/4, right? Because J is 3/2, 3/2 into 5/2.
Yes, sir. Yes, sir.
15/4, that will give you 2, and last factor will be 2, because on into L is on for p orbital, on into 1 plus 2. Oh, sorry, 1 plus 1, that will give you 2. Here you will get S is half, so half into half plus 1, 3/4. So that energy will be how much? So 15/4, here you have 11/4. So 15 minus 11/4, so 4/4. So this factor basically of 4/4. So it will be 1, because this will give you 2 into 4, 8 minus 3. So minus 8 minus 3, 11, 11/4. So 15 minus 11/4 means 4/4. So this factor is nothing but 1. This equals to 1. So that energy J equals to L plus half is giving AH cross square by 2. Okay. And if you calculate second part, that ESO when L is same as well as S is same, but there is only change in J. J is half now. Okay. So that ESO that corresponds to J equals to L minus half, L minus S equals to half. That energy will be how much? AH cross square by 2, right?
Yes, sir.
And
Yes,
that
sir.
factor will be how much?
3/4 minus 2 minus 3/4.
3/4 minus 2 minus 3/4. Very good. So that 3/4 will be gone, and this 2 will cancel with this 2. So it will give you minus AH cross square. Right? So you got two
Yes, sir.
energies. So if you see in diagram, so before spin orbit, let us assume its energy is E0 for p orbit. Now after splitting, this is your 2p 3/2, and that energy will be how much now? That state's energy will be E0 plus AH cross square by 2. Okay, and this energy will be this is your 2p half state, and its energy will be less, right? Because you see that due to perturbation, its energy becomes less. So this is your perturbed energy. So that obviously that energy will be E0 minus AH cross square. So we can calculate this gap now, right? So delta E will be how much now? Simply this minus this. So E naught plus A H cross square by 2 minus E naught plus A H cross square. So it will be simply 3 by 2 A H cross square. Is it clear?
Yes, sir.
Okay. Now we'll discuss the third term, that is Darwin term. In fine structure, you have another term that is Darwin. So लिख लिया आप लोगों ने?
Yes, sir.
Yes, sir.
Okay. बाकी कोर्सेज कैसे चल रहा है आप लोगों का?
सर चल रहा है।
अच्छा, सही चल रहा है ना? एग्जाम का डेट आए आप लोग?
नहीं सर, अभी तक तो नहीं है।
अच्छा
सर अक्टूबर लग जाए अच्छा होता है,
अच्छा, अक्टूबर हो, अच्छा है,
लेकिन सर
ठीक है। हाँ
एक्सपेक्टेड डेट एक्चुअली 16 to 19 है, तो
हाँ
एक्सपेक्टेड डेट 16 to 19 के
हाँ हाँ, नहीं होगा शायद उस टाइम, ठीक है। अब थर्ड टर्म जो है, सो आई टोल्ड यू दैट फाइन स्ट्रक्चर बेसिकली कंटेन्स 3 टर्म. So total energy of your system was E naught. Then you have kinetic energy correction EKE. Then you have spin orbit correction ESO. Now you have third term, that is Darwin term. So that EKE is always negative, right? It makes downward shift of your energy level. ठीक है ना? सारे एनर्जी लेवल को क्या करता है? डाउनवर्ड शिफ्ट करता है. ESO कैन बी पॉजिटिव, कैन बी नेगेटिव. जैसे आपका 2p 3/2 स्टेट को क्या कर रहा है? अपवर्ड शिफ्ट कर रहा है. p हाफ को क्या कर रहा है? डाउनवर्ड शिफ्ट कर रहा है. सो दैट करेक्शन आइदर पॉजिटिव और नेगेटिव. पॉजिटिव corresponds to j equals to L plus S, and negative correction corresponds to j equals to L minus S. Okay, but this is true only when L not equals to 0. When L equals to 0, there is no spin orbit, because term itself is saying that there is a coupling between L and S. And if L equals to 0, there is no coupling, right? So that's why that correction only true, or only this correction is valid for L not equals to 0. But this correction will be 0 when L equals to 0. Now we'll discuss that Darwin term.
Sir,
Hmm.
sir, what is EK?
EKE means kinetic energy correction.
Sir, then how kinetic energy can be negative?
Kinetic energy cannot be negative, but it will shift downwards your level. Yesterday, you was there? We were there, the class?
No, sir.
Okay, I'm giving
Sir.
you hints. I'm giving you hints. When you that expand that your kinetic energy formula, that was how much? P square C square plus M naught square C to the power 4, right?
Yes, sir.
Minus M naught C square. It was there. So when you
Yes, sir.
expand it, you will get P square by 2M. That will combine with your potential energy, and it will give you unperturbed Hamiltonian. And there will be another term, that is P4 by 8 M cube C square. So this factor, when you will calculate this value by using that quantum concept, you will get some negative energy. And that energy yesterday I discussed, but let me write it again. So it was how much? That energy correction EKE was how much? Minus M is C square by 2 Z alpha. Z is atomic number, alpha is fine structure constant, to the power 4 by n to the power 4, then you have n by L plus half minus 3 by 4. So this is your kinetic energy correction. You can see that this energy actually negative. So whatever you have energy E naught, that energy, if you add this term, this is actually negative. So let us assume this energy for ground state, it was minus 3.6 for electron, 13.6 electron volt for hydrogen atom. And this term will give you some minus, let us assume this value is 0.5 electron volt. Now net energy is how much? Minus 13.6. I'm giving just example. That shift will not that much. It will be very less. 0.5
Yes,
electron
sir.
volt. Now energy is how much? Energy will be
-10.
minus 16.1, right? So you have unperturbed energy. Now due to this kinetic energy correction, it will shift downward. Is it clear now?
Yes, sir. Thank you, sir.
Okay.
सर एक्चुअली फीवर हो गया था ना सर, इसलिए नहीं कर पाया.
ओके, कोई नहीं, बाद में कर लेना आप, ठीक है. हेल्थ पे ध्यान दो आप, क्योंकि एग्जाम के पहले हेल्थ बहुत जरूरी है. एंड देयर इज एग्जांपल माई सेल्फ, आई सफर्ड लॉट. कितना आप लोगों का भी ये हो गया, कितना इमोशन हो गया था मैं बेड में पढ़ के. चलो इस डार्विन टर्म को डिस्कस करते हैं आप, ठीक है. So Darwin term, this term is basically completely the details of this term belongs to quantum electrodynamics, QED. Okay, the detailed explanation of this Darwin correction or Darwin term belongs to quantum electrodynamics. So there is one term that I'll discuss now, vacuum fluctuation. ठीक है. So suppose you have chamber. आपने एक चेम्बर ले लिया. दिस इज योर चेम्बर. ठीक है. आपने सारे कुछ सब कुछ रिमूव कर दिया इस चेम्बर से. Light, particle, everything if you have removed, then what will happen? What will be there? It will be vacuum, right?
Vacuum,
Nothing
yes.
will be there.
Yes, sir.
But Dirac ने क्या बोला? No, there will be some particle. So what he suggests, this is your vacuum level. Okay, this is your, let us denote dot. So this is your vacuum level. Vacuum level will have zero energy, and above vacuum level there will be some positive energy states. These states will have positive energy. Positive E means energy. But below vacuum you have negative energy state. So Dirac first gave that concept of negative energy states, right? So that energy states, you have this energy states, and that energy states is basically negative energy. And these states always filled with electron. This states is always filled with electron. So when you are removing all the particle, so there will be vacuum, right? But below vacuum you have particle, that you have states that is filled with electron. And these states always filled, since these electrons are spin half particle, and that electron from upper states, it cannot jump to this state, because these states in general all time filled with electron, and electron is spin half particle, so they will not allow to come any more electron. So when you are removing all the particles, you have vacuum, but below vacuum you have some particle, some negative energy states, and you have particle. And that let me mention that gap. This gap, the energy gap between this is around 1.02 mega electron volt. Now what will happen if you shine some photon, gamma photon, and it's if it has energy on point greater than 1.02 mega electron volt, then this the electron that located in negative energy states, it can absorb this photon and it can jump to positive energy states, right? Do you get what I'm saying?
Yes, sir.
सपोज
Yes, sir.
आपने सारे पहले क्या बोला, आपने वैक्यूम कर दिया तो आपको ऐसा फील हो रहा है कि कुछ भी नहीं है, बट बिलो वैक्यूम यू हैव नेगेटिव एनर्जी स्टेट्स एंड दैट स्टेट्स इज filled with electron. Now let us assume if you are shining some photon, gamma photon, and its energy is 1.02 mega electron volt greater than. Since this gap is 1.02 mega electron volt, so this energy can absorbed by this electron that located in negative energy state, and if it can absorb, it can jump to positive energy state. So obviously that time you can see that particle, right? Now, is it possible if you are shining that photon, if it has energy less than 1.02 MeV, can this electron jump from here to here? अगर आप जो फोटोन है उसका एनर्जी अगर 1.02 मेगा इलेक्ट्रॉन वोल्ट से कम है, at that time can this electron jump from negative energy state to positive energy state?
No, sir. Sir,
Yes.
sir, there is a chance by statistics.
Yes.
Statistically, it is possible, sir.
Exactly. If you apply that Heisenberg uncertainty principle, so let us assume you are applying 0.5 mega electron volt. So there is a energy violation, right? If you are applying 0.5 mega electron volt, so if that electron is jumping from here to here, so approximately there is a violation of energy. That energy is how much? Delta is energy violation, that will be approximately 0.52 mega electron volt. इतना एनर्जी वायलेशन हो रहा है. अगर सपोज मान लो आपने कोई फोटोन को साइन की हो, इंसिडेंट की हो, और इसका एनर्जी 0.5 MeV है, अगर this electron is absorbing this much energy and it is going from this state to this state, then energy violation is how much? 0.52 mega electron volt. So according to Heisenberg uncertainty principle, if there is a violation of energy, that is delta E, then electron should come out from this state to this state within this time, and that is of the order of h cross. तो अकॉर्डिंग टू हाइजेनबर्ग अनसर्टेनिटी प्रिंसिपल, जितना एनर्जी वायलेशन ज्यादा होगा उतना शॉर्ट टाइम में उसको वापसी आना पड़ेगा. सो अगर इंटरव्यू में अगर आपको क्वेश्चन पूछे कि हाँ अगर पॉसिबल है, अगर एक गैप आपका ज्यादा है, अगर फोटोन का एनर्जी कम है, can electron this jump from this state to this state? Answer is yes, but it will not stay long time here. Within this delta time, it should have to come from this state to this state. अगर एनर्जी वायलेशन ज्यादा है, अगर फोटोन का एनर्जी कम है तो ऑब्वियसली एनर्जी वायलेशन ज्यादा होगा. अगर एनर्जी वायलेशन ज्यादा है, ऑब्वियसली दिस टाइम विल बी स्मॉल बिकॉज डेल्टा टी इनवर्सली प्रोपोर्शनल टू डेल्टा ई. तो ये कॉन्सेप्ट समझ में आया कि हाँ सारे आपने वैक्यूम बना दी तो आपके पास ये सारे इलेक्ट्रॉनिक स्टेट है और वहां पे इलेक्ट्रॉन फील्ड होगा. बट ये फोटोन आपको बाहर से नहीं देना पड़ेगा, ये फोटोन आपको बाहर से नहीं देना पड़ेगा. वैक्यूम फ्लक्चुएशन का कॉन्सेप्ट यही है, आपने वैक्यूम बना दी, अब आपने सारे कुछ फ्लैश आउट कर दिया तो वहां पे कुछ भी नहीं है, आपको लग रहा है वैक्यूम है, बट इन जनरल वहां पे पार्टिकल है दैट लोकेटेड एट नेगेटिव एनर्जी स्टेट. अनदर कॉन्सेप्ट इज quantization of EM wave. Quantization of EM wave. Okay. Quantization of EM wave means, so when you are flash out all these photons from this chamber, nothing is there, but still electromagnetic wave is like a harmonic oscillator, quantum harmonic oscillator. So if you remove all that photon, nothing is there, but still you have that much of energy, h cross omega by 2. So you have removed everything. That particle is located at negative energy state, And also, according to quantization of electromagnetic wave, if you remove all that photon, still it has some energy inside the chamber, that is h cross omega by 2. And of course, this energy h cross omega by 2, it will be smaller than 1.02 mega electron volt. But still, this energy can make transition of electron from negative energy state to positive energy state. So when there is a transition from negative energy state to positive energy state, so electron will be here, there will be creation of positron here. So what will happen? You have this much of energy. So electron positron is creating, but within a very small time, electron will jump from here to here. So there will be recombination. When there is a recombination, nothing is there, right? Again, electron will make transition from here to here. So again, you will get electron hole pair. After a certain time, again, there will be recombination, nothing will be there. Okay, so there is a creation of particle, and after some time, that particle will be destroyed. So actually, what is happening? Vacuum is fluctuating because creation of particle, then destroying of particle, again creation of particle, again destroying of particle. So that's why the term vacuum fluctuation. So if you have nothing is there, there will be particle, and due to the quantization of EM wave, if you flush out everything, nothing is there, but still you have this much of energy, h cross omega by 2. And that basically excites that electron from negative energy state to positive energy state. But this energy is smaller than the 1.02 MeV. That's why that electron is coming from excited state to negative energy state. So there is a creation of electron hole pair, and again destroying, creation, destroying. So actually vacuum is fluctuating. जब आपका particle create हो रहा है, that time it is no longer vacuum, right? जब पार्टिकल आपका डिस्ट्रॉय हो रहा है, मतलब जब पॉजिटिव एनर्जी में आपका पार्टिकल मिल रहा है, सो दैट इज नॉट कंसीडर्ड एज वैक्यूम. जब ये पार्टिकल आपका डिस्ट्रॉय हो रहा है, नेगेटिव एनर्जी में आ रहा है, तब आप क्या बोलोगे? वैक्यूम है. जब फिर आपका पार्टिकल यहाँ से यहाँ एक्साइट हो रहा है, सो दैट इज नो लॉन्गर वैक्यूम. व्हेन अगेन इट इज कमिंग फ्रॉम positive energy state to negative energy state, there is no longer particles, obviously it will be vacuum. So actually there is a vacuum fluctuation. Is it clear concept? The concept is clear, everyone?
सर
हाँ.
ये ओमेगा बाई 2 एनर्जी कहाँ से आया?
जैसे आपका हार्मोनिक ऑसिलेटर में आपका जीरो एनर्जी, 0 पॉइंट एनर्जी आपका कितना होता है? एच क्रॉस ओमेगा ही होता है ना, चाहे. हाँ, तो वहीं से आता है वो कॉन्सेप्ट, बिकॉज हेयर इलेक्ट्रोमैग्नेटिक वेव इज नथिंग बट हार्मोनिक ऑसिलेटर, क्वांटम हार्मोनिक ऑसिलेटर. सो इफ यू रिमूव एवरीथिंग, स्टिल देयर विल बी सम एनर्जी.
ओह, बट सर इनसाइड तो वैक्यूम है, तो इलेक्ट्रोमैग्नेटिक वेव कहाँ से आएगा?
हाँ, वही तो मैं बोल रहा हूँ ना, आपने सारे वैक्यूम बना दी, बट ये क्वांटाइजेशन ऑफ इलेक्ट्रोमैग्नेटिक वेव बोल रहा है कि आपने सारे रिमूव कर दो, बट स्टिल देयर इज ए पॉसिबिलिटी दैट यू हैव सम एनर्जी, दैट विल बी h क्रॉस ओमेगा बाय 2. आपने सारे कुछ भी नहीं है वहां पे, फोटॉन्स कुछ भी नहीं है, तब भी इतना एनर्जी रहेगा ही रहेगा, दैट इज 0 पॉइंट एनर्जी. You can't remove this much energy. At least you have that much energy. This is known as 0 point energy.
Okay.
हाँ. So that basically now, ये तो आपका कॉन्सेप्ट गया है, ठीक है. Now ये जो इलेक्ट्रॉनिक का एक्साइटेशन है, एक और वे में पॉसिबल है. सपोज मान लो आपने इलेक्ट्रिक फील्ड लगा दो, इस साइड आपका सपोज मान लो इलेक्ट्रिक फील्ड लगा दो, तो ये पॉजिटिव है, पॉजिटिव कोई सोर्स है, ये क्या करेगा? इसको अट्रैक्ट करेगा, तो फिर इधर चला जाएगा. तो एक पॉसिबिलिटी ये है, बाय अप्लाइंग इलेक्ट्रिक फील्ड you can excite this electron from negative energy state to positive energy state if you have enough strength of electric field. Did you get what I'm saying? These are negatively charged. So if you apply a high amount of energy, electric field strength is very large. So what will happen? This electron will be pulled to excited state. So two way to create vacuum fluctuation. One is quantization of EM wave, another is by applying electric field. So basically the Darwin term is based on application of electric field. So you have nucleus, And let me tell, the electric field created by nucleus that has very high strength. For hydrogen, I am giving that strength. For hydrogen atom, electric field created by electron near to s orbit, that strength is of the order of 10 to the power 11 volt per centimeter. And for uranium, that belongs to, that electric field strength belongs to 10 to the power 18
और
volt per
माइक्रोमीटर है सेंटीमीटर सर
सेंटीमीटर में है, माइक्रो नहीं सेंटीमीटर है ये, ठीक है. So electric field created by the nucleus is so strong, so that much strength can create this vacuum fluctuation. Okay, that much electric field. So I'll draw that diagram, then it will be created. It will be easy to understand. So now let us assume you have a nucleus, then you have s orbit, then you have p orbit, and so on. So you have electron here, and due to this positive nucleus, you have enough strength of electric field. So around this nucleus, you will get electron hole pair. Let me draw it properly. You have nucleus. Can you please mute your mic? This is your s orbital. This is your p orbital. You have electron here. Okay. Now, due to this electric field strength, there will be vacuum fluctuation around this electron. Electron is orbiting around this s orbit, and there is a electron in p orbit also. But you see, there is a electron hole pair here due to that vacuum fluctuation. Can you please mute your mic?
सर कोचिंग का चल रहा है सर मिथिलेश सर कोचिंग का ऑन है सर
Okay.
पैसे आ गए क्या
Okay. So you see, you have electron here, and due to this electric field, around you, around this orbiting electron, you have many number of electron hole pair. And from here, this electron hole pair is coming due to this vacuum fluctuation. So you have electric field here, that is basically creating this. You have positive nucleus here, that has a high electric field, and that basically creating electron hole pair around this orbiting electron. So this orbiting electron is basically shielded by this electron hole pair. So this orbiting electron basically shielded by electron hole pair. Now the potential that orbiting electron is filled by this nucleus will be less as compared to previous case. So if there is no electron hole pair, that potential was how much? Simply for hydrogen case, it is B square by 4 pi epsilon naught. B square by 4 pi epsilon naught R.
कोचिंग का ऑन है सर माइक
कोचिंग का है ना, लेट मी कॉल moment. अरे okay, so you see, due to this vacuum fluctuation, so electron is shielded by this electron hole pair. So initially there is no vacuum fluctuation, so potential filled by this orbiting electron will be how much? Minus c square by 4 pi epsilon naught r. Now since there is a electron hole pair, this electron is orbiting electron is shielded by this electron hole pair. So electric potential filled by this electron due to this nucleus now will be modified. So now due to this, there will be no longer this potential is valid, so there will be some modification. So that modification is basically VR plus S. So that potential can be expanded in terms of Taylor series. That will be VR plus delta V dot S. Okay.
सर ये पॉइंट और एक बार सर बता दीजिए।
कौन सा, ये वाला?
हाँ
हाँ मैं बताता हूँ। देखो, तो आपके पास ये कॉन्सेप्ट समझो कि आपके पास वैक्यूम में कुछ भी नहीं है, ठीक है ना? तो मैंने दो चीज बताया था, एक तो क्वांटाइजेशन ऑफ EM वेव दैट कैन क्रिएट वैक्यूम एंड दैट कैन फ्लक्चुएट, राइट? इलेक्ट्रॉन व्हेन इट विल गो टू देयर हियर, then it will definitely jump because there is a energy violation. Another is like you have enough, if you apply enough electric field, that time also electron can jump from this state to this state. Okay, so there will be creation of electron positron pair, right? Electron positron pair, and if that field strength is not corresponds to this gap, then that electron will again come from this state to this state, and again it will go like this.
फ्लक्चुएशन।
So there are two possibilities there. So in Darwin term, the second concept is there. So you have nucleus. Nucleus has enough electric field strength. So if nothing is there, so suppose you have, this is your S orbit. So nothing is there. Suppose inside vacuum, nothing is there. But still, due to that high electric field, nothing is there means what? There is negative energy state. And that at that negative energy state you have electron is there. So due to this high amount of electric field, there will be creation of electron positron pair around that orbiting electron. So you have, suppose this is your S orbit and this electron is orbiting, right? And due to this high amount of electric field created by this nucleus, you have electron positron pair around this electron, orbiting electron. Now is it clear?
Yes, sir.
Now you see this orbiting electron actually shielded by this electron positron pair. So if there is no particle, then what will happen? That potential filled by this orbiting electron due to this nucleus, it was how much? It will be simply minus general case Z square by 4 pi epsilon naught r. Now since this orbiting electron is shielded by this charged particle, now the potential filled by this electron due to this nucleus will be modified. And if that potential energy is modified, of course there will be change in that energy of this orbiting electron, right? Is it clear?
Yes.
But you may ask me why there is no change in other orbital. Now if you see, if you are going away from this nucleus, if you increase that r from S to, if you go to p orbit, then there will be change, that r will be increased, right? Now the field, that electric field strength will rapidly decrease. So in p orbit, there will be definitely the creation of electron hole pair, but only one or two. So that's why the modification for other orbit other than S will be 0, because there will be only one or two electron hole pair will be created. So that electron orbiting at p orbital, that will not be shielded by this electron positron. So there will be no modification of potential energy for p orbital or other orbital, but for S orbital that is close to nucleus, that will be completely filled shielded by electron positron pair. So there will be modification of this potential, because now the potential filled by this orbiting electron due to this nucleus will be less as compared to previous case. Okay, so that's why there will be modification. So I'm not deriving this part, but I will directly write. So due to this shielding effect, the Darwin term, he completely taken the concept of quantum electrodynamics, and he derived the Darwin term that energy correction is me c square by 2 z alpha to the power 4 by n cube when L equals to 0. Okay, but for other L non equals to 0, it will be 0. Is it clear? So due to this high electric field strength, there will be creation of electron positron pair around this S orbiting electron, and due to this shielding effect, there will be modification of potential, and since there is a modification in potential energy, so of course there will be change in energy. So he has taken the concept of quantum electrodynamics, and he derived the energy correction or Darwin energy is me c square by 2 into z alpha q power 4 divided by nq, where alpha is fine structure constant, and that is only valid when L is 0. But for other orbitals, since that distance is increasing, so field strength will be very less. So there will be creation of only 1 or 2 electron positron pair. So for higher state, that electron, orbiting electron, will not be shielded. So there will not be any modification of potential energy. So there will not be any change in energy. But for s orbital, there will be change. And this change actually, he got positive number.
सर इस
हाँ,
शील्डिंग को सर कैसे हो रहा है और एक बार सर बताइए।
शील्डिंग मतलब देखो, ये आपका चार्ज पार्टिकल है, ये भी आपका चार्ज पार्टिकल है ना। तो ये शील्ड नहीं हो रहा है। जैसे आपका अभी सपोज मान लो यहाँ पे जितना फोर्स था, जितना फोर्स लग रहा था, अब इसके कारण, इस चार्ज पार्टिकल के कारण क्या लगेगा, ये भी इसको फोर्स देगा ना। जब आप इसका पोटेंशियल आप निकालोगे तो पोटेंशियल किसके कारण था, इस चार्ज पार्टिकल के कारण था। अब ये सारे चार्ज पार्टिकल का भी तो ये रोल आ जाएगा ना पोटेंशियल में।
हाँ हाँ यस सर।
हाँ, उसी लिए आ जाएगा, क्योंकि ये पोटेंशियल किसके लिए फिल कर रहा था, सिर्फ इस न्यूक्लियस के लिए। बट ये चार्ज पार्टिकल अब आ गया तो इसके कारण भी तो वो कुछ पोटेंशियल फिल करेगा, बिकॉज दे आर चार्ज पार्टिकल। So that's why there will be modification. So that thing, whatever potential there, it is fielding, it is getting due to this electron positron pair. That thing included in nucleus, and they said there will be modification in potential energy. Whatever earlier it was feeling due to this nucleus, now it will not be that much. There will be modification because this particle is shielded by charge particle. Okay, is it clear little bit?
यस सर। सर और एक सर ये
Yes, Swatan?
सर ये जो मतलब हम बोल रहे हैं कि ओनली इस पर ऊपर ये होगा, जब ऊपर जाएंगे तो फील्ड स्ट्रेंथ रैपिडली डिक्रीज करेगा। बट सर आपने तो एक बात बताई थी कि जब फोटोन का इनफ एनर्जी नहीं होगा तो उस समय तब भी सर कोई फ्लक्चुएशन तो होगा, मतलब डेल्टा टी टाइम पर वो वापस चले जाएंगे ये अपने।
Yes, actually that field strength, that is possible, but very less probability. Okay.
Okay.
Very less probability. So I think time is finished. Tomorrow I'll discuss. Okay.
Okay.
Okay. If you have doubt, I will discuss tomorrow. LAMS also will discuss. Okay. Okay.
Okay. Thank you, sir.
Welcome.
Thank you, sir.
Thank you, sir.
Welcome.